Hello everyone, this is Laveti Manikanta, pursuing BTech second year in VUIT. I am going to discuss about buses in computer organization. In this video, I would like to cover these topics. Firstly, I would like to cover about introduction of buses. Buses in computer organization are very important. We will be exploring a critical component of modern computing that often goes unnoticed. Buses are unsung heroes of the digital world, responsible for connecting various parts of a computer and allowing them to communicate with each other. Without buses, our computers would simply not function. In this presentation, we will delve into different types of buses, their functions, and how they impact system performance. We will also explore bus with bus speed, bus arbitration, bus topology, bus protocol, and bus standards. By the end of this presentation, we will have a comprehensive understanding of buses and their importance in computer organization. What are buses? In computer organization, buses are a communication system that allows data to transfer between components of a computer. Think of it like a highway that connects different parts of a city. The data travels on the bus just like cars on a highway, allowing different parts of a computer to communicate with each other. The purpose of buses is to provide a fast and efficient way for components to communicate with each other. Without buses, each component would need to have its own dedicated connection to every other component, which would be slow, inefficient, and expensive. Buses allow for a more streamlined and cost-effective approach to computer design. Types of buses. In computer organization, buses are used to transfer data between different components of a computer system. There are three main types of buses: the data bus, address bus, and control bus. The database is responsible for carrying data between the CPU and memory or other devices. The address bus is used to specify the memory location where data needs to be read from or written to. Finally, the control bus carries signals that control the flow of data and coordinate the activities of different components. Bus width. Bus width refers to a number of bits that can be transferred simultaneously on a bus. The wider the bus, the more data it can transfer at once, resulting in faster data transfer rates. For example, a 32-bit bus can transfer 32 bits of data at a time, while a 64-bit bus can transfer 64 bits of data at a time. The impact of bus width on a performance can be seen in real-world examples such as video editing and gaming. Video editing software requires large amounts of data to be transferred quickly between the CPU and memory, so a wire bus can significantly improve performance. Similarly, gaming requires fast data transfer rates to render high quality graphics, so a wider bus can result in smoother gameplay. Bus speed. The bus speed in a computer organization can have a significant impact on the overall performance of a system. Bus speed is measured in megahertz or gigahertz, which represents the number of cycles per second that the bus can transmit data. A higher bus speed means that can be transferred more quickly, resulting in faster processing times for applications and programs. For example, if a computer has a bus speed of 800 megahertz and another bus has a speed of 1.6 gigahertz, the latter will be able to transfer the data at twice the rate of the performer. This can be make a noticeable difference in the performance of resource intensive applications such as video editing or gaming. Bus arbitration. Bus arbitration is the process by which multiple devices on a bus compete for the control of the bus. It is necessary in computer organization because without it, two or more devices could try to access this bus at the same time, causing data corruption and system crashes. To prevent this, the bus arbitration protocols are used to determine which device has priority access to the bus. One example of bus arbitration is protocol, the round robin method, which each device takes turns accessing the bus. Another example is the priority method, where certain devices are given higher priority access based on their performance to the system. Bus protocol. Bus protocol is a set of rules and procedures that govern the communication between the devices on a computer bus. It defines how data is transmitted, received, and acknowledged, ensuring that all the devices follow the same standards of for communication. Bus standards. Bus standards are essential part of the computer organization, providing a common interface for different devices to communicate with each other. There are several bus standards used in modern computers, including PCI, USB, and Wi-Fi. PCI Peripheral Component Interconnect is a high-speed bus standard commonly used for connecting expansion cards such as graphic cards and network adapters to the motherboard. USB is a widely adopted standard for connecting peripherals like mice, keyboards, and external hard drives to a computer. FireWire, also known as IEEE 1394, is another high-speed standard used for connecting devices like digital cameras and external hard drives. Conclusion. In conclusion, buses are a critical component of computer organizations that facilitate communication between different devices. We discussed the different types of buses, including data, address, and control buses, and how they work together to transfer information within a system. We also explored the importance of the bus width and speed, as well as the bus arbitration topology, protocol, and standards. Understanding buses is essential for anyone working with computers, from hardware engineers to software developers. By grasping the fundamentals of the buses, we can design more efficient and effective systems that can be handled increasingly complex tasks. So let's continue to explore this fascinating topic and push the boundaries of what possible in the world of computing. Thank you.